A data warehouse. A data warehouse is a relational or the multi-dimensional database that is designed for query and analysis. Mostly the transactional data is stored in a OLTP system, but the data warehouse are not optimized for the transaction processing, which is the domain of OLTP system. It usually consolidates the historical and analytical data derived from the multiple sources. The transactional data is stored in the multiple databases, but these data are extracted and combined in a unified form in a data warehouse. Data warehouse separate analysis workload from the transactional workload and enable an organization to consolidate the data from the several sources. This picture can summarize the entire description of a data warehouse. What the data warehouse is, it is a central location where the consolidated data extracted from diversified multiple location sources into a central database. This database contains all the relevant data into a single format, and entire data is stored in at one place. Data warehouse is maintained separately from the organizational operational data. Operational data contains the data related with the different transactions. Like suppose customers are coming to the bank, and on the daily basis, thousands of customers or the hundreds of customers are making the transaction at a bank branch, but these transactions will not be reflected into a data warehouse. These transactions are stored in a system which is known as a transactional system. So a transactional system is basically responsible for keeping all transactions in a organization, while data warehouse does not reflect these transactions. These transactions are accumulated in a separate database which contains all the data from these diversified transactional databases into one place. That place is referred to as a data warehouse. So the process of ETL, which is the extraction, transaction, and loading, the data is stored in the data warehouse by the ETL process. And the cubes of the data are generated, which is known as the online analytic processing. The data warehouse is typically used to connect and analyze the business data from heterogeneous sources. The data warehouse is the core of the business intelligence system, which is built for the data analysis and reporting. The business intelligence user will use this data from the data warehouse and generate the reports of the data. And several reports can be combined in the form of dashboards. The dashboard is the ultimate goal of a business intelligence system, where the each and every key performance indicators are reflected on one page, and that page is helpful for the management and the company for different units, how the different units are operating in the company. That can be visualized by dashboards. So that is why the data warehouse is an important place where the data is placed, and business users will take the data from the data warehouse. What are the key features of a data warehouse? The data sources are there. Suppose the data is stored in Oracle or SAP or SQL Server. These are the different sources. These sources contains the transactional data at the different stores or the different segments of the company. And this data will be taken into the data warehouse. We cannot directly use the data in the visualization purpose from these transactional sources. So that is not a recommended way to utilize the data in the business intelligence. In the business intelligence, we store the data from these diversified sources into a data warehouse, and then that data warehouse will be used for business intelligence reports and dashboards. The data collected from the various sources are stored in the various databases, cannot be directly visualized. A data warehouse is a blend of technology. It is and components which aids the strategic use of data. A data warehouse is electronic storage of a large amount of information by business, which is designed for query and analysis instead of transaction processing. It is a process of transforming data into information and making it available to the user in timely manner to make the difference. So these are the very important utilizations of data warehouse. The company's data warehouse is a company asset which contains all historical data, and that data will be used for analytic purposes. And business intelligence users and the business intelligence system will take the data from these data warehouses. The formal definition of data warehouse is it is a single, complete, and consistent store of data obtained from the variety of different sources made available to the end user in what they can understand and use in the business context. This is the definition by Barry's Bavelins. Means what? Means we have diversified data sources, and from these diversified data sources, the data is extracted and transformed into a single format. That single format will be used for making the data cubes. The data warehouse is a collection of integrated subject-oriented databases designed to support decision support function, where the unit of the data is non-volatile and relevant to some moment in time. So these are the four important characteristics of our data warehouse. Integrated means the data is integrated in a single format. Subject-oriented databases, suppose the data is organized, the sales data is organized in a separate table and separate databases. The products tables are separate, and the customer information are stored in the different tables. So the data is categorized and stored by the business subject rather than by applications. Integrated means these subjects are collected from the diversified sources and stored in a single place in a single format. So the single place and the single format is one of the important characteristic of data from the different sources. Then time variant means the data is stored in the data warehouse in the snapshot form. Snapshot form means one layer of data is stored, and if we populate the data in the data warehouse in every month, then another version of the data is created. The previous month data will not be updated or edited or appended for the purpose, but a new instance of data is stored in the data warehouse. The data warehouse contains the historical layers of data that will be utilized, and this type of databases are very safe and accurate, and it contains the historical instances of data. So in the data warehouse, the data will not be edited, will not be deleted, will not be updated. Instead of updating or deleting or appending the data, a new instances are created, and that new instances will be used for analytic purposes. The data is non-volatile means we cannot delete the data in our data warehouse. So that is a very traditional and very important concept in data warehouse, because the data is very important and user cannot alter the data in the data warehouse. So instead of altering the data in the data warehouse, a new instance of data is created in the data warehouse, and what changes the user want to store in that data can be stored as a separate instance in the data warehouse. Data warehouse have several advantages. Data warehouse is faster and more accurate. Data warehouse is not a product a company can go to purchase. It need to be a design by strategies, by goals, by different sort of objectives. The users of the data warehouse perform data analysis that are often time related. For example, include consolidation of the last year's sale figures, inventory analysis, profit by product and by customer. More sophisticated analysis include trend analysis, data mining, which use the existing data to forecast the trend and predict feature. The data warehouse typically provides the foundation for the business intelligence environment. Metadata is defined as the data about the data. Metadata means we have to explain and identify the different elements of the data, and that elements of the data is stored in a separate segment which is known as metadata. For example, on the web pages, it contains the description of the page content as well as the keywords linked to the content. This metadata is often displayed in search result by search engines, making its accuracy and details very important. Since it can determine whether a user decides to visit the site or not, this information is usually expressed in the form of the meta tags. The name of the author, the date created, the file extension, the date modification date, the file size, these are the example of metadata. Yeah, a file can be identified by these characteristics. So these are the characteristics of the data stored in a file. So we can call it a term metadata for it. Metadata in data warehouse define the, so what is the source of data? That is a flat file, relational database, or other object. Where from these files are coming, which source is included for sharing and representing this file. Metadata used to define the which table is source and which table is the target, and which concept is used to build the business logic called transformation to actual output. Data in the data warehouse usually stores for many month or year of data to support the historical analysis. The data in a data warehouse is typically loaded through an extraction, transformation, and loading process. During the extraction, transformation, and loading process, the description of data are stored on a separate segment, which is known as metadata. Data warehouse is nothing other than a relational database. Relational, this is also a transactional data is stored in the databases, while the data warehouse is also a database. So both are the database, but their objectives are different. Their characteristics are different, and we can organize the data in the different formats. Suppose we have a transactional system stored in a database in SQL Server at one store, and data is stored in Microsoft Excel worksheet in the another store. Then in data warehouse, we store the data in a single unified relational database model, which can be which can have a single file format and single structure we have for that data. In the data warehouse, the data is represented in the form of data cubes. These cubes will help us to obtain the data in the multi-dimensional structures. Suppose we want to, sometimes we want to see the data date-wise, sometimes we want to see the data, the country-wise. So these are the dimensions. So we can see the data in the multi-dimensional way in the data warehouse. Database terminology, records are the basic term which represent a row. In SPSS, we call it as a case. In Excel, we use the term row for entire record. But a record contains the data item which are related to one customer or one unit. Suppose the customer name, the customer address, the customer email address, the customer phone number. These are the elements for one customer, and we have the multiple rows for all customers. If we have the relational records that form a field, that form a table. So if we have a multiple records, that can be stored in a table. The table is nothing, it is a collection of records. But these records are related to each other. Suppose in a table of customers, so we have all the records of customers. We cannot store the record of employees in our customer table. The database is what? Database is a collection of related tables. Suppose in a company, we have suppose in a company, we have a table of products. We have a product table. And we may have a customer table. We may have a employee table. We have inventory table. All these tables are related to one company. That is why we can call it as a tables are related. If these tables are related, they form a database. And database management system is a collection of programs. It is a code. This code is used to appending the data into an inventory system, or we have one code which is used for deleting an item from the inventory. This is the code for which is used for updating an inventory item. So these are the several files. These files are the coding or the codes or the program files. These collected files are making a system which is called a database management system, or DBMS. So DBMS is a set of program, while database is a set of data. So that is a major difference between the DBMS and databases. Relational databases are those in which the data is linked with the table. Suppose customer table is bifurcated into two segments: customer master table and customer transaction table. So this is customer transaction table. So the customer ID is a key feature and the customer ID is a key feature here. And these two IDs are to be related in a relational database. So if I want to, there is a single element of each customer in a master table, but it have multiple transactions here in the transaction table. But the customer one transaction number one for the customer number one. This is the transaction number two for the customer number one. This is the transaction number three for the customer. So customer number one have a multiple transactions. So we may have a one-to-many relation here. So there is a one customer, but it may have many transactions in this table. In similarly, the customer number two has a multiple transactions here. Customer number three have several transactions here. So that is why such type of system is known as a relational database, relational databases. And the same way, the relational management database management system are the programs or the collection of programs which control a relational database system. We have different tables: the department table, the department employee table. These are the employees table and salary table for the employees, and titles and department managers and so on. So several tables are there, and all tables are integrated via relations. And these relations are maintained with the help of the key field and primary key field and secondary key field and so on. So these tables are interrelated to each other so that they are making a relational databases. So popular relational database management systems are Oracle, the Microsoft SQL Server, Sybase, and Microsoft Access. These are the database system which we can use for implementing the databases or the relational databases in our organization. The major characteristic of data warehouse is the data in the data warehouse is multidimensional. Multidimensional means we have the cubes of data, and data can be extracted in the several dimensions. Like suppose I want to have the data for a specific city, all customers from a specific city, then that can be taken from a data warehouse. In the other dimension, at the other instance, I need the data for a specific month. So the data from the cube can be extracted by month basis. In the same way, we can access the data in the different dimensions. So the multidimensional databases, the data is presented to the user in such a way that is to represent a hypercube. Multidimensional arrays, which are where each individual data value is contained within a cell accessible by the multiple indexes. Users of the data warehouse performs the data analysis that are often time related. For example, consolidation of the last year's sale figures, inventory analysis, the profit by product and by customer. The profit by product is the product dimension, and the profit by consumer is another dimension. More sophisticated analysis includes the trend analysis and the data mining, which uses the existing data to forecast the trend or predict the future. The data warehouse typically provides the foundation for the business intelligence environment. Hypercubes play a very important role in organizing the data and making a very successful business intelligence environment. So this is an example of a cube. This cube is maintained with the help of 3 dimensions. The products are in one dimension, the time is in another dimension, the geographical area or the region is another dimension. So we can have a three-dimensional online analytic processing cube with the slicing operation. This is the table in which we can have specific product. So there are the multiple layers in which the products are stored. If someone need product A, so it will take a scorecard or a spreadsheet from this cube and will get the data of that specific product. Similarly, if we are interested in the time manner, then the transactions in a timely order, the sales volume of a specific region on the variable time and product. So that can be obtained. Here the time, variable time and product. So the time is important feature here, but geographical information is extracted. The data can be obtained in a single dimension from this multi-dimensional cube. A data warehouse has a characteristic of client server. Client server, the data is stored in a server where the data is stored in the form of a data warehouse, and then the client system will use the data from. So this is a data warehouse which is stored in on a server, and from this server the multiple clients will use the data from the same server. So the client number one is using the data for making some reports related with the sales, and this is the user which is making the reports related with the production. So this is the production report, and this is the sales report, and we have inventory report. So these are the clients. These are the clients which are using the data from a data warehouse which is stored on a cloud or on a server. So this client server architecture is a basis for a data warehouse. The data warehouse real time or the right time. This is called active data warehouse. The traditional definition of data warehouse contains the data is non-volatile data, but nowadays data warehouse can provide us a real time data or the active data. The data can be accessed on the real-time basis from a data warehouse. This is a characteristic which is found in the newly available data warehouses. Data mart. Data mart are basically the smaller versions of the data warehouse, which is made for a specific dimension. Suppose a data warehouse is data mart, sales data mart is constructed, or marketing data mart, or operations data mart. So these are the different characteristics by which we can have the smaller part of the data warehouses, which are known as the data mart. The smaller version of the data warehouse are known as the data mart. Data marts are designed for a specific subject. Data marts are focused on a specific area, hence they draw the data from a limited number of sources. Time taken to build the data mart is very less as compared to the time taken for building an entire data warehouse. Data warehouse provide a new design which can help to reduce the response time and help to enhance the performance of queries for reports and analysis. Data warehouse, data in the data warehouse, which is made for the enterprise-wide data. Means the data warehouse, we have data related to the overall company or the overall enterprise, while the data marts contains the data belongs to a specific to the department. Multiple subject area are the objectives for the data warehouse, but the single objective, single subject are the focus for the data mart. Limited data sources we have for our data mart, because data marts are for specific departments and which is a smaller scale, while the multiple data sources or larger scale data we have in a data warehouse. The data warehouse contains more memory as compared to the data marts. Longer time is needed for implementation for the data warehouse, while the shorter time is required for implementation of a data mart. The data mart, sometimes the data marts are formed by uh, data warehouse, while the other time we may have the other variants. The dependent data mart, independent data mart, and hybrid data mart. These are the three important types of data marts. In a OLTP system, the data is consolidated into a data warehouse, and then the separate data marts are to be formed. This is called dependent data marts. While we have the OLTP system and data mart is directly formed from the OLTP system. This is called uh, independent data mart. While in a hybrid data mart, we have some of the data we may have from the data warehouse, but we may have data from the online transaction systems directly. So that is called a hybrid data mart. So depending on the need, depending on the situation, depending on the scenario, user can decide which type of design in a data warehouse is used for building the data marts in an organization. This is the data framework of a data warehouse. The ETL process is shown. We have to select the data, then we have to extract the data, transform the data in a unified file system, and then integrate and load. This and these are the different sources. Data is obtained from the different sources. We have the data in the ERP system. The entire bank's data is stored in the ERP system that may have a legacy data in which we have a traditional and historical data. We may have several point of sale terminals are generating the data. All these sorts of data are extracted and in a data warehouse, it is organized and stored. If we are organizing it for an entire enterprise or for entire company, we call it as a data warehouse. If it is made for a specific subject, we call it as a data mart. And for the purpose of uh, the data is replicated because one instance of data is extracted, then another instance will be extracted in a different instance, in another instance. Means we have a layers of data here in a data warehouse. Then if the data is stored in a dependent data marts, then marts are formed: marketing, subject, engineering, finance, and the different for the different subject area the marts are found. There is a possibility that without the different data marts, the data can be extracted to the BI visualization purpose. The reports are formed, the dashboards are created, and multiple visuals are used uh, for viewing the data. So this is the ultimate objective of the business intelligence system, to have a quick view and the instance view of the data, which is generated by the different BI tools. Legacy data means the national registers of citizens and electoral rolls are collectively called as a legacy data. So legacy data information is stored in an old or obsolete format. or computer system that is therefore difficult to access or process. This legacy data may have one source of data. Extract, transform, cleans, and load. Another factor is the data has to clean. In the data warehouse, we have a clean data. And we may have a data from the directly to the data mart. This is called as an independent data mart. We may have a data warehouse first created, and then data marts are generated, which is known as a dependent data marts. So these are the different operation in ETL process. Dimension table, fact table, and measures. These are the three important characteristics of our data in our data warehouse when the cubes are generated. The dimensions are what? Dimensions are the dates dimension, the product dimension, the customer dimension. These are the different dimensions we can. This is the in a three-dimensional system, the date, product, and the customer. And this is the e-commerce company. The subject is the e-commerce company, and different attributes are there. Means the delivery date, the shipment date, the order date, the product ID, the customer ID, the name of the customer, the address of the customer, the product name, the product type. So these are the different attributes. So what is the difference between the dimensions and the fact table? Fact tables contains the facts, while the dimension table contains the different dimension. So in a fact table we have uh, transactional data which reflect the actual amounts, actual figures are stored in a fact table. Suppose the customer, how many amount is spent in purchasing the items. So these purchase amounts are stored in a fact table. These purchase amounts are related with some dimension table. Suppose from where these products are purchased, which are the list of products which includes in this fact table, and what are the different time dimensions in which these purchases are made. So the time dimension, the customer dimension, and sales dimension. These are the different dimensions which are related with a fact table. And measure is what? Measure is a single quantity. Suppose different prices are stored in a sale table. Then measure is what? Measure is a single quantity which represent the total. The total grand total sale. This is the sale, product wise sale. Product one, the sale is this. For product two, the sale is this, and so on. The measure is what? Measure is this total of all of these. So in a quantitative sense, the quantitative fields can be accumulated and gathered by specific quantities which are referred to as measured. The tables, fact tables contains the facts. The dimensions table contains the dimensions, means the products are the dimensions, the companies from where we are purchasing, these are the different dimensions. The dates are the dimensions. Fact tables are surrounded by multiple dimension, which makes schema. The schema is what? Schema is technologically characteristics of a data warehouse in which the different fact tables are surrounded by and connected with the different dimension table. So as you can see that the date is a dimension, the product is a dimension, and customers are the dimensions. And the dimensions are surrounded by different fact tables. The fact tables contains the product ID and the number of units sold. How many units are sold? Number of units sold is a measure, and the product ID is a dimension key. This is related with the another table which is known as a dimension table, and that table contains the product name, the product characteristics are stored in a product table, but in the fact table we contains only the fact about the number of units sold. So that is a relation between the fact table and dimension table, and different measures are included in that. The fact is a measure that can be summed, averaged, or manipulated. This is a measure in fact table. This is a measure which can be summed, counted, averaged, or manipulated. A fact table contains two kinds of data, a dimension key, because it is related with the dimension table. So this product which has the ID this, the entire details of the product is stored in the dimension table, which contains all information about this product. So every dimension table is linked with the fact table. So this type of structure is known as schema. The dimension table and the fact tables are related or integrated by themselves and form a schema. तो इसका star schema, snowflake schema, galaxy schema. Galaxy schema is also known as the fact constellation schema. In a star schema, one fact table is surrounded by multiple dimension table. So as you can see that the employees, department ID, the age, the name, the first, this is the employee table. And department ID is linked with the another table, which is the table of departments. So the department is a dimension here. So all the information related with the employee departments, that information is actually stored in a dimension table, while the facts related with the employee are stored in a fact table. A fact table is surrounded by multiple dimension table. So a fact table contains multiple dimension keys. The dealer ID, it is connected with the dealer table. And the model ID, it is connected with the model dimension. The model name, the model ID, the model information is stored in a dimension table, which is known as a model dimension. The branches data are stored in a branch dimension. So the branch dimension contains the name of the branch, the code of the branch, the location of the branch. So these are the different attributes of the branch. These attributes are stored in another fact table, in another dimension table, which is known as the branch. Units sold is a measure. Revenue is a measure. These measures are stored in a fact table. The fact table, if one fact table has several dimension table, so this type of structure is known as star schema. While if the fact table is surrounded by different dimension and each dimension is split into the further dimensions, so this is called as a snowflake schema. So in a snowflake schema, the dealer information is splitted into the another one, which is a location of the dealer. So that this dimension is further subdivided into the another table, which is the dealer location dimension, and country dimension is also be represented in a separate table. So if fact table is there and the information in dimension table is further subdivided into the different sub dimensions, so this type of schema is known as a snowflake schema. So the dealer dimension table is split into the location and country. The product dimension table is split into the product and the variant. So the dimension table in a snowflake schema are normalized. Normalized means it is broken into the different additional tables which represent the further dimensions. The last segment of the schema is the galaxy schema. In the galaxy schema, we may have several fact tables. So in the snowflake schema, we have a single fact table. In the star schema, we have a one fact table which is surrounded by the several dimension table. But in a galaxy schema, we may have more than one fact table. The fact table, this is the product fact table. This is the revenue fact table. So in a star schema, the product fact table and the revenue fact table both are in one table. Now it is split into the two tables, and this is surrounded by the dimension table. So this is the branch dimension. This is the date dimension. The date dimension is a common table in the revenue fact and in the product fact, but the product dimension is a single table in dimension way, and dealer dimension is also a single. This type of galaxy schema is also known as the fact constellation schema. Multidimensionality is an important feature in a data warehouse because users can obtain the data from the cube with the help of different dimensions. The user can draw the time dimension, the user can draw the data in the sales dimension, by region dimension, or the time dimension. The multidimensionality is an important feature of data warehouse. OLTP system and analytic processing system. Analytic data warehouse is an objective of OLAP, while the relational databases or transactional system are the part of the OLTP. The OLTP contains the most current data. Users' transactions are stored in the OLTP system. OLTP system are useful in running the business. Immediate data is stored in the OLTP system. OLTP system provides the primitive and highly detailed data, and which is much accurate as compared to the data we have in a data warehouse, because these transactions help us to immediately organize the transactions. OLTP system are much faster and they have a number of records access in tens. So all bank transactions made by the customer is an example of OLTP system. While in a data warehouse, useful in analyzing the business. In analyzing the business means we can have the data with the large amount of data is stored in a data warehouse, and the data is updated or extracted from the OLTP system in a timely fashion. And we cannot change or modify the data in a OLAP system, because in a OLAP system, the data is stored and organized in such a way that the user cannot edit or modify the data frequently from a data warehouse. So these are the differences between the OLTP and a OLAP system. We can compare the OLTP system and the OLAP system with the help of car speedometer. In a car speedometer, the odometer is the OLEP because it reflects the overall mileage run by the car. So it is useful for a long-term purpose. In a OLEP system, the transactions are stored in a long time period, and we have to analyze all of these information for future trending. While the speedometer is an example of OLTP system. If the speedometer is not working in a car, it is quite difficult to run the car because you cannot see the immediate speed of the car. While if the odometer is not working, so it may be not affect the individual transaction of the immediate transaction of the car. So it is very important that analytic system are very helpful, but the immediate transactions are much important and accurate as compared to the OLTP, because if OLTP system failed, then there is no need and no way to organize an OLTP system, because all the OLTP system are basically based on OLTP system. So the first priority is to run the OLTP system, successful OLTP system, and then the data is taken from these OLTP system to make the OLTP system. These are the different characteristics in a queue. This is called a roll up. Roll up means the data cubes climbing up a concept hierarchy for a dimension reduction. The following diagram illustrates how the roll-up work. In a roll-up, we have a three dimensions here. Chicago, the New York, the Toronto, the another state we have. But these dimensions are summarized with the help of countries. So the data is splitted in the location or city wise. If we collect all the cities by countries, and we have reducing the dimension, so this is called a roll-up process. So in a roll-up process, we have a multiple dimensions here. That dimensions are roll up and make up consolidated segment. So these two informations are added because these two are the cities in the US. So these two numbers are added and make a new number, which we have 2000 we have. In the similar way, the information in Toronto and other countries of Canada are added, and we have the roll up is an important characteristic, and roll down, drill down is is a vice versa of that. So drill down and roll up. So these are the two important characteristics. So in a queue, several times we need a roll up process, and some other time we need the drill down process. So this is the drill down. The dimensions are further subdivided. So here we have New York, Chicago, and in the times are in a quarter manner, but these quarters are split in the months. If the quarters are split in the months, then this process is known as the drill down. The drill down will give us a more expanded version of the queue, while roll up will gives us and reduce the number of dimensions in a queue. So these are the two important features in OLEP systems. Slicing is an important characteristic. Is a one face of the cube is known as a slice. Suppose I am adding all of these dimensions in this cube. If I have add all of these dimensions in a cube, then we have only a surface spreadsheet. So it is a single table or in a single spreadsheet. So all of these informations are added, and they make it a single entry here. So this is a slice operation. So in a queue we have a roll up operation, we have a drill down operation, we may have a slicing operation. And this is the dice operation. In the dice operation, we have two-dimensionally the data is added. This is the one dimension which is reduced here. So from a 3 by 3, we have a 2 by 2 cube. 3 by 3 cube instead of 3 by 3 cube, it is this is known as a dice operation. So a cube can be molded in any direction. It can be expanded as it can be contracted or reduced. Uh, Pivoting is another characteristic of a cube. Thank you very much for this video, and after completing this lecture, I will try to demonstrate the implementation of data warehouse in SQL Server. That's all for today. Thank you very much.